All right, deep divers ready to talk numbers. Ever wonder how computers crunch those digits, to make everything from apps to websites actually work?
It's really mind-blowing when you think about it, right?
Totally. So today, we're going deep on integer expressions. But don't worry, it's not as scary as it sounds.
No, not at all.
We've got some excerpts from a programming textbook, even a few code snippets to help us out. It's like we're going behind the scenes of how software really works.
I like that behind the scenes. It is fascinating. We just take for granted all those complex calculations our computers are making all the time.
Right. All the time.
But once you get these basic building blocks, it really opens your eyes to how powerful programming can be.
Absolutely. You know me, I'm a visual learner, so I love that our textbook has this handy flowchart. It's like a roadmap, right, for programmers to see how a program should work step by step.
Exactly. Flowcharts are great for that. Helps you map out the logic before you even write a single line of code. Like this one, for example, it shows how a program could calculate the total cost, say, if you were leasing a car.
Oh, interesting. So you'd input what, like your down payment, your monthly payment amount, how long the lease is.
Yep, exactly. All those things.
And then the program would take those numbers and use them to figure out the total cost.
That's the idea.
Okay, that makes sense. But where do these integer expressions come into play? Sounds kind of intimidating, like something from advanced algebra class.
Huh. I promise it's not that bad. Actually, it's pretty straightforward. Integer expressions, they're basically like these mini equations, little math problems, within a program.
Okay.
They tell the computer how to work with those numbers we were just talking about.
So it's like you're giving the computer specific instructions using math.
You got it.
Ugh.
Here, let me give you an example. There's this one from the textbook, total cost equals down payment. Payment per month, numItems.
Whoa, okay.
That right there, that's an integer expression in action. What it's doing is it's telling the computer to get the total cost, first multiply the monthly payment by the number of months in the lease, and then add the down payment.
Okay, yeah, I see it. But I have to ask, what about those parentheses? Those seem important. Could you leave them out and get the same answer? Or...
Yeah, that's a great question. And it actually highlights a really crucial concept in programming and in math in general, and that's order of operations. Remember PEMDAS or BODMAS from back in school?
Vaguely. It's like the order you do the math in, right? Multiply before you add or something.
Yes, exactly. It stands for parentheses, exponents, multiplication, and division. Those happen from left to right, and then addition and subtraction also from left to right. Just like in regular math, the order you do those operations in makes a huge difference in the result, and that's true in code too.
So those parentheses in that example, they're telling the computer to multiply the monthly payment by the number of months first before adding the down payment.
Exactly. You got it. Without those parentheses, the computer would follow its normal order of operations and might calculate the total cost wrong.
Wow, okay. Parentheses, they're important. Makes sense. But while we're talking about these little details, I noticed all the spaces in that example code. Is that just to make it look nicer, or does the computer actually care about that?
That's a great question, and it gets into the idea of coding style, which, believe it or not, is a big deal in the programming world. Now, the computer itself, it doesn't really care about extra spaces. But for us, humans who are reading and writing this code, having a consistent and readable style is super important.
Wait, really? You're saying a single space can make a difference?
Oh, yeah, absolutely. When you have consistent spacing around operators, like those plus and multiplication signs we were looking at, it makes the code way, way easier to read and understand, especially as those programs get more and more complex. Imagine trying to read a paragraph, but there were no spaces between any of the words. It would be impossible.
Oh, yeah. Total gibberish.
Total gibberish. Code's very similar. Good spacing just makes it more digestible.
So it's all about making it easier for other programmers, or even yourself later on, to actually understand what the code's supposed to be doing.
Exactly. Readability is so important when you're collaborating on code, when you're trying to find and fix errors, and even just to understand your own code when you come back to it later, after you haven't looked at it for a while.
So good coding style is kind of like good grammar, keeps everything clear.
Yeah.
But I feel like with any rules, there's always exceptions.
Right? You're right. Programming languages, they can have their quirks. There's always going to be that one exception. Take the unary minus, for example.
Unary minus. Okay, now that sounds like a made-up word. What is a unary minus?
It's actually pretty simple. It's just a way of saying you have a negative number. Like in code, you might see a minus sign right before a variable, like ichord, something like that.
Okay, and that's different from like the regular minus sign you use for subtraction.
Exactly, exactly. It's not about doing math. It's about this is a negative value. And the funny thing is, even though we usually put spaces around plus and minus signs, with that unary minus, you don't.
Oh, okay, so that's the exception, right? It's like the minus sign has a different meaning when it's used like that.
Exactly. It's all about those little nuances of how these programming languages work. And speaking of nuances, you know what else can be tricky? Commas.
Oh, yeah, my textbook mentioned something about that. I was surprised. I mean, we use commas in numbers all the time, but not in code.
Nope, not in this case. In programming, when you've got integer literals, basically just whole numbers, you can't use commas inside them. So like 1 million, we'd normally write that as 1,000, right? But in code, you'd write it as 100,000, no commas at all.
Wow, that seems like it could really mess you up if you're not used to thinking about it.
For sure. It's one of those easy things to miss, even for experienced programmers. It just goes to show you got to pay attention to those specific rules of whatever programming language you're using. Those little differences, they matter.
Yeah, no commas in code. Got it. So while we're talking about things that can go wrong, my textbook also mentioned integer limits, something about how if you try to use a really, really big number, it can cause problems.
Oh yeah, that's a good point. Computers are powerful, but they do have limits. Integers, they have a maximum value that they can handle. And that can vary a bit depending on the system you're using, the programming language, that kind of thing.
So if you go over that limit, it's like, I don't know, trying to fit an elephant in a shoebox. It's just not going to work.
Exactly. You'll probably run into what's called an overflow error, which can make your program crash or just start acting all weird.
Yikes, that does sound a little scary.
Mm-mm.
So choosing the right data type from the beginning, that's super important, huh?
Absolutely. You really got to think about how big those numbers might get and pick a data type that can handle it. Careful planning, it goes a long way.
Planning ahead. Always good advice. Now, shifting gears a little bit, I was reading about something called incremental development, which seems to tie into all of this. So tell me more about this incremental development. What does that even mean?
Well, it's basically a way for programmers to, build software in smaller chunks.
Okay.
So instead of trying to build this perfect, completely finished program all at once, they start small, keep it simple, and then just add more features, more complexity as they go along.
So it's kind of like if you're building a house, you wouldn't start with like putting in the fancy windows before you even have any walls built, right?
Exactly, yeah. Good analogy.
You'd want to lay the foundation first and then go from there.
Exactly. My textbook actually has this example about calculating somebody's age in days. So instead of worrying about leap years and all that complexity right away, you might start with, just a basic calculation that assumes there's 365 days every year.
Okay, makes sense. And then once you've got that part working right, you can go back and add in all the other details.
Exactly. Exactly. This whole approach, it's called incremental development, and it just makes the whole programming process less overwhelming, and it helps you catch mistakes earlier, too, because it's much easier to spot a problem in a small chunk of code than in a gigantic, massive program.
Yeah, that makes a lot of sense breaking it down.
Yeah.
So as we wrap up our deep dive here, all about integer expressions, what's the big takeaway for our listeners today? What do we want them to remember?
I think it's really cool to think that these basic concepts, they're actually the foundation for so many programs we use every single day. Everything from figuring out your grocery bill to streaming music online, it all comes down to these fundamental math operations running behind the scenes.
It really is. It makes you appreciate the complexity of this technology we have that we kind of take for granted.
Absolutely. And the coolest thing is, once you understand those basic building blocks like we've been talking about today, you can start to get really creative with programming.
I like that, getting creative. So to all our listeners out there, here's a little challenge for you. Think about those everyday calculations you make. Could you try turning them into code? You might be surprised by what you learn. Who knows, this might even be the start of your own coding journey.